Hi, this is a short video on how to search for things. So there are different ways to find stuff when you're searching for it. And if you know what you're looking for, you need to look and you need to look through a lot of things. There are different ways to achieve what you want, that is finding what you're looking for. So for example, if you have uh, a lot of different objects like this, and let's try to see if we can kind of fill one of them. And you're looking for the red one. So immediately when we're looking for something with our eyes, we have an ability to recognize nice patterns, and we can easily see that this is the red one. But sometimes we're looking for a needle in a haystack, so we might be looking at a very large amount of things, and we want to find something. Oftentimes I've been looking for something like Lego bricks. So you want to find a specific red Lego brick with a specific layout or something like that. And there's just so much Lego to go through, and you need to find that one little brick. So, and you need to know where it is so you can build something from that. This is also a problem that we often encounter in software. We want to find something. Probably you've tried looking at web pages and there's a lot of content and you need to find some specific place on that web page. So you use Control F to find it and you type some of the word and it will magically find the text. So how do you actually find something in programming? That is the interesting part. So I'm going to show the first way of finding stuff when we don't really know much about the stuff we're looking through. So I'll explain more later. Let's go into some programming. So I've just created this small Java program, and the first thing I'm going to do is I need some data so that I can start looking for something. So let's start by creating an array. So I'll go int array and I'll call this numbers and define it as a new int. And of course I need to write the size of this, and let's just put something simple like 20 elements into this. And I'll make a method for printing this array. So private static print numbers. Sorry. And let's just do like this. And maybe let's make this a class variable instead. Class variable. So we'll say private, if I can spell it, private static. So now we have a class variable here, and we can access it from up here. So this will say for each int I in numbers. This will run through each and every element of the numbers, and we'll print that out to the screen. We won't use print line because that will create a new line, so I'll just say print, and then I would put I here, and then let's print a new line as well. After printing all the numbers, we'll do a new line. Maybe we need to separate them somehow, so I'll just put something like a space like this. Let's see what that looks like. So I'll just say print numbers. Let's see. So what we can see is we get a list of numbers and they are all zeros. That's because Java automatically initializes all integers as 0. So that's pretty easy. So let's try to make some random numbers. So we want random numbers instead of these. So I'll make another method, private, static, void, randomize numbers. And I'll make a small method for randomizing. So again, we'll make a loop, numbers length, and inside of that loop, I'm going to say numbers of I, set that equals to some random number. In order to do that, I need something for randomness, so I'll use the built-in random class in Java, like that. And I can use now this random generator to get an integer, and I want to set a bound size so we won't get like incredibly big negative numbers and positive numbers. So just some number from 0 to 99. It will go just one below that number. So let's see that. Oh, of course, I need to randomize it first. So now I randomize the list and I print the numbers. Okay, so now I get some random numbers here. Another cool thing I want to do, I'll put a seed on my random, so I'll always get the same list. If I do this again, I'll get a new list, which is kind of confusing for what I'm going to do now. So I'll just put something in here like 1337, and now we get this list here. And if I do it again, I'll get the same numbers. So they are randomized from this number here. You can see my videos on random numbers if you want to know how to do that. So, and why it works like that. So now I've randomized and printed them. So let's say now I want to find one of these numbers. Let's say I want to find the number 23. We could have multiple 23, like we have 22 here and 22 here. I just want to find the first one. It doesn't look like we have more 23. We only have this one. So I want to find out where it is in the list, because we're searching for something. We're looking for where it is. And in an array like this, we want to know the index of this number. There's no easy way to do this. We need to search for it ourselves. So we're going to use the simplest way of searching for something, which is really called linear search. And what we do in linear search is we look at items one at a time. We start from one end, and with this example here, I look here, then I look to the next one, 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 next one. Oh, this is the one I'm looking for, and I found it. So it's basically, if you have a big bucket of things that you're searching through, you pick one out of the bucket at a time, you look at it, you discard it if it's not the one you're looking for, and when you find what you're looking for, you have it. Okay. So here, what we're looking for is really the index of this. So we want to loop through all of the numbers. So I'm going to make a for loop that does that. So I'll make a normal for loop, and I'm going to make it go through numbers length. So that means this loop will go from 0 until the length of numbers minus 1, because it says less than here. So when it becomes the length of the list, the length of the array, it will skip the length because it says less than. If I put equal to here, it would be less than or equal to. I would get an error because I would be outside of the last element, because the first element in an array is called 0. So it's a zero-based index. That means that 21 is at 0, this is at 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So we should find 14. I could do that. I just manually sequentially searched this. So let's see what we can do. So we're going to say that if the numbers at the ith index is equal to 23, which is the number we're looking for, then we're going to print out we found, and then we put 23 here at index, and then we put the index here where we found that, which will be equal to I because we're using I as the index here. So let's see. Let's try to do that. Let's try to see if we can do that. So it says it found it at 11 and 14, and I actually, that's my bad because it is actually at both 11 and 14, so we found both of them. So that's kind of cool. I didn't see that, but the computer obviously did. So we could of course change this. Instead of looking for that, we can look for, let's call it item instead. And we'll change that into item. And up here, I'll say int item equals 23. And now we can look for 23. We could also look for 22. I can see that's in multiple places. 22. So both at index 3 and 19. So this is basically what we call sequential search. Sequential meaning we start at one end, we go through everything until we find the one we're looking for. This could also mean this is kind of the most stupid search we can do because it's very slow. We have to look through a lot to see this. So, but it looks like it's very slow, but computers are really fast. So I just want to show you something that will maybe make you rethink that this should be slow. So right now it's looking for 22. Let's do something interesting. So instead of having only 20 here, I will put 1 million here. The underscores, you can ignore those. These doesn't matter. It's just to make it easier to read the number. So putting them there is the same as not putting them there. It's just a way of showing that. So now all of a sudden I have a million numbers, and both my print and my randomize should still work. Printing a million numbers to the screen should be pretty slow. So let's see what happens. So you see it's printing away, and now it's done. So it did take like 2 seconds or something like that, but it wasn't that slow, right? So it seemed a bit slower, but let's try something interesting. So now I won't print it to the screen. I'll just remove that part and I'll run it again. And now you see it went a lot faster because it didn't need to print all of that. It only printed in all the places where it found the number 22. And still, because we're using the same random sequence, 3 and 19 are still there, but it also finds it at all of these other places. And still the slow thing is printing them out. So you can imagine that if I outcomment the place here where we actually print the items, then we need to do something here. So if I find them, I won't do anything. So now it basically runs through the same thing. It just doesn't print it to the screen. it finishes within milliseconds. So it's not really that slow to find something. The slow thing here is to print it out. Yeah, so that's it. So sequential search is slow, but in most cases it's fine. Sequential search is really the only way to find something. So let's say we have a big bucket of Legos and we want to find one of these Legos. The only way we're going to find that Lego is to rummage through the entire box until we find the one we're looking for. We can spread them out on the floor and use our eyes or something. We can do other stuff, but basically the only thing we can do is take them one at a time and look at them and then try to find it. The reason why I'm saying this is that there are actually no other ways of finding stuff than searching through one at a time. With that said, it's not really true anyway. We can actually search things faster, but then we need to have extra knowledge about what we're searching. For example, if we have all our Legos collected in boxes, let's say we have all our red Legos in one box, like this, and all our yellow Legos in another box, and all our blue Legos in the last box. Let's draw something like this. This is one box. This is another box. This is a third box. So now if I want to find my red Legos, I first look in my red Lego box and then I can do sequential search. So if it's this one I'm looking for, I have to go 1, 2, 3. So immediately by having it built into 3 boxes, I only have to search about 1/3 of them if they are equally distributed. So this is still sequential search within the box, but we can do stuff so that we can actually find things faster if we know something about it. So we can sort things in order to find things faster. And this is also why we archive things in alphabetical order and do stuff like this at all. It's because we can find things a lot faster if we archive it the right way. So that's it for this video. This is only about sequential search. The next video is going to be about something called binary search, where we will actually sort the items before we try to find the one we're looking for. And when we've sorted the items, we can find things a lot faster, like incredibly much faster than we can this way. And in the next video, I'll also show how to search for other things than just simple integers. Bye.